As you can see in the slides, we were supposed to do this talk together with Werner Kyle, the spec lead of this JSR. However, Werner is really sorry that he had to go to Devoxx, Belgium, in order to do a different talk about Java Money JSR. So we're going to be together today. And let's go back, right? Let's go back to 1999. What happened there? How many of you can still remember what were the main topics of 1999, right? First of all, of course, we had Bill Clinton with all these kind of crazy actions he was taking. And then we did have Nokia 5110, right? But we also had the arrival of the very first Macintosh. On top of that, there was Euro, but, of course, the millennium bug, right? Which kept us busy as software engineers. How many of you were software engineers back then in 1999? Wow, one. That's good, okay. We can do the talk together. No, I'm just kidding. So, NASA had a different issue though. NASA was only busy with launching their Mars Climate Orbiter to space, right? To Mars, actually. So, what was the Mars Climate Orbiter, first of all? Let me give you a few very basic details about the spacecraft and the mission itself. It was launched on 11th of December 1998 with an overall mass of 338 kilograms, and it costed $125 million. We're going to talk about the amount of money that NASA spent later on. For now, it is important to also mention the reasons behind this mission, right? So, of course, the reasoning behind this mission was to study the Martian climate, atmosphere, and surface changes. However, this is the entire result of the mission, right? This picture costed $125 million. So I'm actually wondering, what did go wrong back in 1999? That the entire world was going into a different era, and NASA was about to go to Mars. What did go wrong? First of all, a contractor from the Lockheed Martin system engineering made a mistake. So he actually used the imperial units, or the US customary units, to put it better, in order to calculate the total impulse created by the thruster firing of the spacecraft. However, in the software specification provided by NASA, it was clearly mentioned that they should use only the metric system, right? And to put it directly and straight to you, what did they use actually? So they actually used pound force seconds. Lockheed Martin used pound force seconds, whereas NASA software specification clearly stated that they should be using Newton seconds. How many of you know the factor that is there, the difference in the factor? Anyway, it is 445. So you can really imagine what went wrong if you are off in your calculations by such a factor, right? And I can go a bit deeper actually by showing you what was the difference between the actual trajectory and the planned trajectory. Of course, the planned trajectory was about to move the spaceship to 26 kilometers above the surface of the Earth. However, given the 4.45 factor that Lockheed Martin's calculations were off, that was only 57 kilometers above the surface of the Earth. And why was that not good? Because, of course, in order for an item to survive in space, it needs to have a minimum altitude of 80 kilometers, right? So just imagine, somewhere in the atmosphere, it disintegrated and disappeared. Okay. However, NASA didn't really want to put the blame on Lockheed Martin. So at some point, they had to communicate something to the press, right? So that's why Edward Weiler had to actually communicate that the problem here was not the error. It was the failure of NASA's system engineering and the checks and balances in our process to detect the error. That's the reason we lost the spacecraft, right? So, I'm kind of wondering at the moment, did we learn anything from the past? Are we still learning anything from the past? At least, for this particular case, we can learn three main things. First of all, read the software specification. If Lockheed Martin would have read the software specification, this mistake or this mishap would have never happened, right? So that was one. Second of all, use JSR 385 instead of primitives, right? And I will show you later on the reason, of course. Third of all, and the most important one, I would say, do fail fast, right? Do not really rely on the checks and balancers to discover problems. Do fail fast. Do throw errors where you can. However, that was not the only unit of measurement mishap in the history of humanity. There are even more. First of all, 12th of October 1492. What happened? Columbus miscalculated the circumference of the Earth because he used Roman miles instead of using nautical miles. And of course, he ended up in Bahamas, but he thought he was in Asia. And this is the reason the Native Americans were called for Indians 500 years later. So what did Columbus do wrong? He used Roman miles instead of nautical miles. One more units of measurement mishap. Second of all, the so known as Gimli glider, right? So in around 1983, an Air Canada flight had a problem. Somewhere in the middle of the flight, the airplane ran out of fuel. And what happened? Just imagine what would have happened, right? You're in the middle of your flight, and the airplane runs out of fuel. Luckily, there was an airport nearby, which was actually not being used actively. It was really in a maintenance mode, and luckily, that day there was a social happening with kids going around and people having fun and different events taking place there. So the captain decided actually to land the airplane. Luckily, nobody was dead, only a few minor injuries. The reason behind this mishap is that normally the captain of the plane computes and calculates the fuel that he needs and provides the result of this calculation to the ground crew. However, the ground crew didn't really try to verify the result provided by the captain, and they did accept the mistake of the captain. What was the reason? 1983, right? The reason was that this mishap happened around the time that Canada went over from using the imperial system or the US customary units into the metric system, right? So there were quite a few issues there. One more mishap, Clarence the tortoise, right? 2001. What happened there? Los Angeles Zoo decides to loan for an indefinite time, for an indefinite period, this really big tortoise to, of course, the Moore Park College. So I'm someone who is someone from the staff of Los Angeles Zoo, and I'm calling Moore Park College, and I'm telling them, hey, could you please actually prepare a cage for a tortoise of a mass of 250? They forgot to say kilograms. So what did the Moore Park College do? They created a cage for a tortoise of a mass of 250 pounds. So guess what happened? the tortoise arrives, right? The guards go home to sleep. They called it a day, of course, at 5 to 5. Nobody knows, right? And in the middle of the night, the tortoise wrecked the cage. One more unit mishap. Now, I'm gonna turn it in not that a positive tone right now, but it doesn't really matter. There is a tone of medication dosage error problems or mishaps as well. For example, how many of you have heard up until now, take 5 teaspoons of medication X? How could it happen that we are using nowadays teaspoon as a unit of measurement, right? I mean, personally, I have at least 5 different kinds of teaspoons at home, right? Which one should I use for taking that dosage, right? That dose. So actually, the same applies between grains and grams. I'm going to tell you, take 5 grains. You might think I'm going to take 5 grams. So there is a whole set of errors and mishaps that normally happens around the units of measurement. I would say that's why we do have JSR 385. But first of all, we are technical, and let's understand what the problem currently is. So what's the fundamental problem today? What are we going to try to solve? Primitive Java types are just primitive types. And why is the word Java in a parenthesis here? Just because the same applies to any other kind of programming language, right? So you could have in the parenthesis C++, right? Primitive C++ types are just primitive types. So what does that actually mean? It means they are not good enough to represent quantities. And of course, let me get that once again. So primitive Java types are just primitive types, as in building blocks to build other types. But then I'm just wondering, right? Using a primitive to represent a quantity, how good is that? Isn't that fundamentally conflicting with OOP and DDD? Let me show you one example. First of all, how could we define the speed of light? Let's see some code, right? That could be a potential solution, right? That could be a potential representation of the speed of light. Or to put it more good, we could define a constant with a better naming, right? However, still it's not that pixel perfect. What about this one? Let's make our constant a bit longer, right? To represent it better. But still, you do have here the amount in double. So actually, you're using a type representing just a number to represent a quantity which has a unit. Isn't that bad? Oh, yes. Yes. Isn't that bad, actually? I just want to see an entire black box on top of it, right? How should it be? It should be like that. So what are we doing here? We're using a built-in property that contains both the value and the unit, right? We do define it as a static final. Still, we are talking about constants, right? So we use the speed of light as a built-in type, as a built-in property. And as you can see, we have both the value and the unit. So we do have the value of the speed of light, 100 whatever, and we do have the kilometers per hour, which is the unit. So at some point, okay, Thodoris, you're telling us a few things. However, I'm still not convinced. Why not actually building my own library, right? And I could agree, actually. I could agree. However, there is a ton of things you need to take care of while building your own library, such as development. Of course, you need to start converting or providing ways to convert kilometers per hour to meters per second. Then you need to cater for other converters, other unit formatting, and so on and so forth. And once you're done, of course, you need to maintain it, right? It will not keep developing by itself. And of course, the very best one, upgrades and extensions. You need to take care of that as well. So actually, here comes my question to you. Are you a domain expert? Do you know the SI system that well that you can create your own library to deal with these kind of peculiarities of the SI system. And I can at least answer this question to you from my side, because I didn't do so a year ago that I got introduced to this JSR. I didn't know all these peculiarities, but I can definitely tell you that I'm not a domain expert, even after a year. No, the SI system is really complex to deal with. So, let's meet. Hi, Thodoris Bais, or Thodoris Bais in English. I'm a member of the expert group of JSR 385. I work as a Scrum Master for ABN AMRO Bank, which is a bank in Holland, in the Netherlands. And other than that, I'm also helping others find their own motivation via my own company, Agile Leaders. Enough about me, nobody cares about me. Let's see what JSR 385 is all about. So, first of all, what do we see here? We see an evolution, right? An evolution which happens physically in the nature. So JSR 385 is actually the evolution of JSR 363, which was the very first effort to actually start introducing units of measurement API JSR on top of our JDK, right? Of course, second point, the reason for upgrading JSR 363 to 385 was that last May, if I'm not wrong, May 20th, 2019, yes, we had an SI system redefinition, right? So we definitely had to also apply those newly agreed concepts to our JSR. And third of all, let's extend it some more, right? So given that we already tried to improve it, tried to create a new JSR, let's also talk about or cover and support modularity and Java 8 and onwards. What are the basic concepts though? I would say 3 main concepts, but we're gonna see a few more. First of all, dimensions. That could be length, right? Units, that could be the meter, and quantities, which could be something like 5 meters, right? On top of that, though, you do have also other things, like prefixes, right? So milli, micro, mega, kilo. You do have converters, as I mentioned, to convert from kilometers per hour to meters per second, for example. You do have formatting as well, because we're talking about representing the result or printing out the result, so you need to also have some formatters in this JSR. And systems of unit, right? Because we might be in Europe, but our friends in US and UK decided to use their own system, right? So in Great Britain, for example, we do have the imperial systems of unit, right? And in the US, we have the US customary units. Of course, there are a few cases still where they are using the Roman units of measurement. I don't know if we have any traditional people in this room, and any other kinds of local systems of unit, such as Norwegian. Okay, really good. However, let's see something in action. I have prepared a few demos. Just 1 or 2 we're going to see in the very beginning, and around the end of the session, I'm going to show you something we built within our adopted JSR day. But for now, actually, before going there, let's see what this exercise is going to be about. What would be the easiest example to work on for the JSR 385? What would be the easiest example to start investigating the units of measurement the units of measurement API? Yes. BMI, body mass index, right? So what is the body mass index of a person? And we'll take myself as an example. So what is body mass index, first of all? The body mass index, let's read the definition together, is a person's weight in kilograms divided by his or her height in meters squared. How could we do that? How could we start using JSR 385 out of the box? That's it, right? All you need to do is to just include the INRIA dependency in your POM file. INRIA is a name we came up with and stands for, actually, it is the reference implementation dependency. And so it is actually the dependency for the API itself. And this is all you need to do. Before going straight to the code, let me give some more details about quantities. Once again, let's go together to read the definition of a physical quantity, because it will play its own role in the examples. A physical quantity is a physical property of a phenomenon, body, or substance that can be quantified by a measurement. That came, of course, from Wikipedia. So that can be quantified by measurement. And how could this be split up for the example of the speed of light? You could see it like that, right? As we've seen earlier in the slides. So we have the value and we have the unit. And one more quote about the physical quantity, right? The same physical quantity can be represented equivalently in many unit systems. What did we see? We saw an example of the speed of light, right? So what we said right now can be represented like that, right? In many systems of unit. Let's have a look at the exercise. So we want to calculate the body mass index of myself, for example. First of all, before actually doing that, let's see how we could define the two quantities we need for this particular example and just print them out, right? So we're gonna just define a mass and a length quantity and just print them out. So let me just get my IntelliJ here. Is it visible? Yeah? Okay, cool. So what are we doing here? As we've seen earlier, we keep mass as a built-in property. Of course, we give it a proper name. And we're just using our quantities class to represent the quantity of mass by providing, of course, both a value and a unit. As simple as that, right? And then, of course, we just print it out. Same applies to the length quantity. So we will define a built-in property of a quantity, sorry, of a length type. Then we'll just give it a proper name. My height, I think I'm still 180. And yeah, the units of a meter. And let's just print it out. Let's see what that's gonna print out. So let me come here, actually. Isn't that cool? Right? All you need to do is to just print out the previously defined quantity. Did you see this? It's cool, right? Isn't it? I mean, you define something here using the units of measurement API. You give it a value and a unit, and if you're going to print it out, everything comes out of the box. You don't really need to care about anything more. So, okay, that was one example, right? Same happens for the meter itself. However, let me just go back to my presentation. However, that was one, as I said. What would be the next one? Let's talk about, indeed, calculating the body mass index of a person. So what do we want to do here? Divide the mass by the square of the height, right? And print out the result. How are we going to do it? Let's have a look at it once again. Back to my IntelliJ, and here all the way to this example. And what do we have here? As you can see, up until this point, everything is quite similar or exactly the same, to be honest, to the first example. Okay, but now, what are we going to do? We're going to actually print the body mass as well, right? So how are we going to do it? Let's say I don't even know what type I should give to that quantity, to the newly created quantity of a body mass index. So I'm using this very known wildcard. I put it as type agnostic, and I'm just doing the calculation. I'm just dividing the mass by the height squared, right? And that's it. Or we can also do it the other way around. We can do it with another way. We can just, first of all, multiply height by height and then divide that result with by the mass, right? So two different ways, and we'll see there is a small, very slight difference here. So let's run this example as well. The first two lines are what you saw earlier as well. However, here we have our body mass index, right? Cool, eh? Or at least I like it. And you have, of course, the unit itself. Everything comes out of the box for you. You don't really need to take care of anything else. That's it. All you need to do is to just define quantities, type agnostic, I don't know, make the calculations, or define how the calculation should be, print out the result, done and dusted. Let's go to the next one. So those two were two examples, two quite basic examples. And let me actually go. No, I don't want you here anymore. We had JFOL 2 days ago. So units, right? What about units? We do have the base units, like cantella, kilogram, meter, second, ampere, Kelvin, and mole. On top of that, we also have a few derived units, which come as a result of more work around the base units. I can also give you a few examples about the multiples itself, right? So actually, kilometers, right? That's a multiple. Same with millisecond. Megameters, what is that? Is it even used? And kilosecond? I mean, okay, we can definitely say an hour has 3,600 kiloseconds, but how would you react if I told you, please, come back in 60 kiloseconds, right? They are rarely used. A few more words about dimensions. Length, of course. Time, mass, electric current, thermodynamic temperature, amount of substance, luminous intensity, and yuan. Why yuan? Because, of course, we need we have some cases like when we need to calculate an angle where we don't really need any unit, right? So we need to also cater for the absence of any dimension. So, and of course, if someone asked you what does the force consist of, that is, of course, length times mass divided by the square of time. Very shortly, a summary table with all the base quantities, base units, and dimensions. However, we're here today, right? And we're talking about unit API. So why don't we also talk a bit about the math behind that? So let's start with equality and equivalence. And of course, let me start with a few examples around units. A kiloohm and a millihertz are always different. Same applies to a kiloohm and a milliohm. Those ones are different as well, right? A kiloohm and a kiloohm, though, are equal. What about Newton? 2 kilograms meters per square second. Those ones are equivalent. And what about kilogram per square meters? That one is equivalent to milligram per square millimeters, right? So pause here. Kilograms per square meters is equivalent to milligrams per square millimeters. So I'm just wondering right now, should we better use actually functions to normalize expressions into what could be considered closer to the base unit? Think about it, function to normalize an expression which is considered closer to the base unit. Let me walk you through very quickly to the quantities because I want to also show the corresponding example for kilogram per square meter. So, same applies to quantities for the example I told you, which actually means that 1 kilogram per square meter is equivalent to 1 milligram per square millimeter. So you could use a function to normalize the 1 milligram per square millimeter into 1 kilogram per square meter. However, it always depends on your case But there are also a few corner cases, like when we are talking about a paint for a very small device where you might want to use, or where it is better to actually use milligram per square millimeter, right? And of course, once again, here, 1 kilo is different to 1 millihertz, 1 kilo is different to 1 milliohm as well. 1 kilo and 1 kilo are equal, and 1 newton is equivalent to 1 kilogram per square meter. Okay, cool, up until now, right? What about 1 kilo ohm, which is equivalent to 1,000 ohms? As you can see, it's not only about comparing the values and the units, but you also need to convert to one base unit and do the comparison based in one reference unit. Quantity addition. How are we going to do that? I'm going to show you just a few examples, and then I'm going to explain the theory behind that. So, first case, right? Let's go back to school. 1 ohm plus 1 ohm equals 2 ohms. 1 ohm plus 1 milliohm equals 1.001 ohms. 1 milliohm plus 1 ohm equals 1,001 milliohms. What about 1 ohm plus 1 meter? That one does not compile. So we're not even letting the user to go into the compilation process. Remember what I said in the beginning? Fail fast. So what is the theory behind that? We said that, first of all, please use the first unit if you can. If you cannot, and it leads to an overflow error, do fall back on the second unit. Otherwise, if both units lead to an overflow error, just throw it, right? Okay, cool. So we talked a bit about what happened in 1999. We talked a bit about how you could use, or we just saw how you could use the JSR 385 in order to have everything ready on top of your IDE and to start calculating units of measurement and providing the results. But we also started doing the math, right? So what about having a quiz today, right, on math? And I came from the Netherlands. So how many of you have ever been to the Netherlands? 1, 2, 3, 4, 5. Cool. So you know stroopwafels, right? For the winners of this quiz, I do have a dessert. So if you guessed the answer right, please come find me after the talk. I also have Utrecht jug stickers, but this is a different story, which we will cover later on. So that was enough to start talking about our math quiz for today, right? And here's my question. How much do you think is 0 degrees Celsius plus 0 degrees Celsius? Okay, let's see. Let's go together here, right? 0 degrees Celsius. I heard it, right? I heard it. For the ones who already told me so, please come afterwards. Or maybe 0 degrees Celsius. Now things start getting more complicated. Hi, welcome. Thank you. Third one, 273.15 degrees Celsius. Okay, let's see. By the raise of hand, how many of you think it is 0 degrees Celsius? The first one. The first one. Okay, keep this question. Are you also up for the second 0 degrees Celsius? Good one. Okay, who is up for the second one? Nobody. I'm the only one. Okay. What about the third one? 273.50. Cool. Okay. So, all of you are right. All the three answers are correct. And why is that? Let's see it together. Okay, so first of all, let's investigate and examine the very first scenario where we have two absolute temperatures. So what happens when we have an absolute temperature? Let me get it straight. Let me get the rule straight. For an absolute temperature, 0 degrees Celsius means 273.15 Kelvin. Please come afterwards for a stroopwafel. You're good. as they were from this side. So, 0 degrees Celsius for an absolute temperature means 273.15 Kelvin. So, the sum of 2 times 0 degrees Celsius would be nothing else other than 546.30 Kelvin, right? Which, of course, is equal to 273.15 degrees Celsius. That is one, right? That is one. Okay, 2 absolute temperatures. First scenario. Second scenario, let's talk about one absolute temperature and one temperature change. And what did we say in the first scenario? For an absolute temperature, 0 degrees Celsius means 273.15 Kelvin. What happens on a temperature change, though? For a temperature change, 0 degrees Celsius means 0 Kelvin. So, for this particular case, 2 times 0 degrees Celsius would give us a sum of 273.15 Kelvin, which, of course, in turn gives us 0 degrees Celsius, right? Yes, I know, SI system. I'm going to come back to the degree Celsius unit later on. I'm not done yet. So, third scenario. So, up until now, we covered the scenario of 2 absolute temperatures, 1 temperature change and 1 absolute temperature. What's the third one? Guess what? 2 temperature changes. And what did we say on the previous scenario? A temperature change, or on a temperature change, 0 degrees Celsius means 0 Kelvin, right? So, the sum of 2 times 0 degrees Celsius here would be nothing else than 0 Kelvin, which is, of course, equal to 0 degrees Celsius. I had the same. I told you I'm not a domain expert, right? Yeah, that's a good one with the temperatures, right? So, actually, all the 3 answers are correct. And as you can see, it always depends on whether we are talking about an absolute temperature or a temperature change. And to be honest, this is something we hadn't modeled initially. And that's why I'm actually saying, are you a domain expert in your system? Do you know the SI system that well? And do you know all the peculiarities of the SI system that you can write your own library, which can take care of all these kind of crazy things? And again, I need to mention it for the 3rd time. I am not a domain expert. I would be surprised if someone here in this room was one. One more word about degrees Celsius. I will build it gradually. I will build it up gradually. First of all, of course, it's a cool unit for some people to use or to measure temperature, right? It provides you with a very cool scale between 0 degrees and 100 degrees, right? However, keep that in mind. I will show you a few examples later on. For now, a few words about multiplication, right? So, kilogram times meters equals kilogram meters. Kilogram times millimeters equals kilogram millimeters. Gram times kilometers equals gram kilometers. Should you leave it as such, or should you better convert it to kilogram meters? It depends on your case. What about meters times meters? Equals square meters, of course. Kilometers times kilometers equals square kilometers. Millimeters times kilometers equals millimeter kilometers. Should you leave it as such, or should you better convert it to square meters? It's up to you, and of course, always depends to the particular case you're investigating. Micrometer times meters equals micrometer meters. Should you leave it as such, or should you better convert it to square millimeters? Once again, what about the quantities? Quantities, however, are quite straightforward. As you can see, you just need to multiply the value and the unit. However, there could be a few strange effects in the way you're going to represent the unit. As you see, here we have the times and the middle dot. So please do keep an eye on that as well. Division, same one, more or less. Kilogram divided by meters equals kilogram per meters. Kilogram divided by millimeters equals kilogram per millimeters. Gram divided by millimeters equals gram per millimeters. Should you leave it like that, or should you better convert it to kilograms per meters? Think about it when you're about to see something like that. Square meters divided by meters equals meters. Meters divided by meters equals 1, right? Kilometers divided by kilometers equals 1 as well. And what about the next one? Kilometers divided by meters equals kilometer per meters, which is equals to 1 kilo. Keep an eye on that. Please be careful, be cautious. Quantities, however, are quite straightforward. Once again, you just need to keep an eye on the way you're gonna express the unit, as I said. So, one more word about the powers. The square of a meter is square meters. The square of kilometer is square kilometers. The square of square meters equals meters to the 4th power. Quantities, more or less the same. Quite straightforward. Do take care. Do be cautious. Do be careful on the way you're gonna express the unit itself. So, I told you, I could come back, right? I would come back to revisit the degrees Celsius unit, or I don't know, representation. It's not a good unit to work with. Let's see a few examples, first of all. Cool, right? The square of Kelvin equals square Kelvin. You know what's next, eh? What about this one? What is the result of degrees Celsius squared? Is that equal to Kelvin minus 273.15 to the 2nd power? Of course not, right? Okay, what is this one? I don't like it, right? Meters times degrees Celsius, is that equal to meters times Kelvin minus 273.15? Of course not. However, I need to admit there is also one more corner case here, where you might want to use the meters times degrees Celsius. For example, you could say, you could use it for an isolation material, right? You could say, for example, isolation material X could hold up to 5 degrees Celsius per meter, right? And why is that actually? Still, I'm on the corner case, eh? Don't get me wrong. Why is that actually? Because, remember, can you recall what I said? I said isolation material X. So what happens actually for an isolation material? Isolation material means temperature change. And for a temperature change, of course, degrees Celsius is kind of better. Don't get me wrong. It's better to use actually. However, quantities, what is this one? I'm not going to pronounce it. I'm definitely not going to pronounce it. What is the result of 0 degrees Celsius squared? I don't want to pronounce it. That's why you shouldn't use degrees Celsius. And one more corner case. Sorry. What is the result of, or what is 1 millicelsius equal to? Is that equal to 1 millikelvin or 273.151 Kelvin? Well, I'll give you the answer. Let's not waste more time on the peculiarities of the SI system. The answer is 1 millikelvin. And I can understand you're going to ask me why, and I'm going to reply, I don't know. I'm sorry, but as I said, it has to do with the peculiarities of the SI system. So, parsing units and quantities. Let's talk a bit about that as well. There are many different symbols and many different ways to express and parse units and quantities. As you can see, we do have the example of the speed of light, where you can just use the slash or thousand separator without thousand separator, decimal point, star, as you can see, and one more example with the times symbol. However, when it comes to superscripts, you could express it in 2 different ways. For a superscript, you could either use the HTML sub-element or just the -1 Unicode for superscript. Of course, we do have more examples like the middle dot or the caret, as you can see here. And the kilometers per hour slash, as I said, you can use in order to represent a unit. What is that one? What is kilometers per T? T, from our Java, from our beloved Java, stands for the local representation of time, right? However, be careful on the specific locale you're going to use. For example, if I'm in Norway and I'm going to try to parse kilometers per T in Norway, that will be parsed as kilometers per tone. You don't want that. So do keep an eye on that as well. And of course, miles per hour, no slash, no middle dot, no nothing. Systems of unit. I touched a bit upon the systems of unit in the very beginning of this talk. So let's see what we have here, right? We have the metric system, right, which is our very known and where we are also very familiar with. We do have meters, kilograms, seconds, amperes, and the base units, as we said. Then we have the imperial unit, derived by the English, right, with foot, ounce, pound, gallon, and so on and so forth. What else? US customary units, right? There is something more on the US customary units. Of course, US customary units is more or less the same or quite comparable, quite similar to the imperial system. However, in US, they are using one particular unit to represent two different units, as we know them at least. So to get that straight, in US, they are using gallons to represent both gallons, but also horsepower, right? And I'm sorry, I was not pointing a finger, right? So Roman units of measurement for the more traditionals of the room, right? Foot, ounce, Bais, ounce, yeah, I don't even want to pronounce them. I don't know if anybody uses them. And Norwegian, so other local representation of units of measurement. I told you I would try to also show you something more. So within the Utrecht Java user group, we also organized and adopted JSR Day last June, where we hosted spec lead of this JSR, Werner Kyle, and we actually created 3 demos. The guys were really cool to come up with 3 demos. What I'm going to show you right now is actually a demo, a Vaadin demo the guys came up with, just using the very basic case of our JSR. So, Vaadin application, right? Sorry, it doesn't really matter. So we just have the initializer class here of a Vaadin application, or let me actually show it differently. Let me first of all go to the browser and show you what the guys came up with, right? So first of all, I'm gonna just refresh the page. So what did the guys came up with? A list of units of measurement, at least with the units of measurement, from 2, right? It always depends on what you're gonna use. So for mass, it automatically refreshes the from and to units. And let's see what we can do here. Let me say that, let's say that we would like to convert a value of 5 kilograms to 5 grams, to whatever grams, right? So this is the result. And what about from kilograms to pounds? That should be the result, right? What else do we have here? Of course, our beloved degrees Celsius, right? I would like to convert it, of course, to Kelvin. So 50 degrees Celsius, I hope we will never experience something like that, is this amount of Kelvin. How did we build that, or how did the guys build that? Of course, we have a very basic Vaadin application, the very the initializer class here, and then we do have two more classes, sorry. Then we have, of course, the conversion view, which is just the setup for the Vaadin application, and I'm gonna show you directly where the magic happens in the conversion form class. As you can see here, once again, some very Vaadin-specific configuration in order to configure, thank you, the from and to, and then just a configuration on the units based on what the user is gonna see. I will share the GitHub repository for that, looking also at my time. What what is the meat of this example, of this Vaadin example? Here, you take the source unit from the select box, right? You also take the desk unit, and you are just using your unit converter from the units of measurement API. You are just writing one single line of code, right? And then you're setting the value in the result by doing, of course, some parsing of the double, right? One single line to do that. It's cool. I'm going to share it later, also looking at the time. So, to wrap it up for today, let me just go back to my presentation, right? So, what do we have? What is left right now? What was the What was the fundamental problem again? Primitive Java types are just primitive types. They're not good enough to represent quantities. A few words about the current status of our JSR. We recently went live. We are now at 2.0.1 version. You can see more about. You can read more about it in the JCP page of our JSR and the GitHub repositories. And one word about one more word about the Java community process. The Java community process is actually a platform where you could see yourself in a win-win situation. So, for example, you can contribute some time, you can invest your time, you're giving some time, you're volunteering yourself by writing some code, documentation, and of course, you're getting something back. Your name is going to be written, and your name is going to be mentioned in the contributors list, right? And I would like to take myself as an example. 1 year ago, I just started by fixing some documentation. Then I helped in the migration of the entire API to JUnit 5. And then we ran our adopted JSR day. 1 year later, I'm here representing the JSR, and a big thank you to Werner Kyle, of course, for giving me this opportunity. Speaking of Werner Kyle, we're actually also running for an associate seat in the upcoming executive committee elections. So, how many of you are already JCP members? One. That's great. Okay, that's cool. Please evangelize the word. So, for the ones who are already JCP associate members, as of November 5th, the ballot opens for the executive committee elections. So, Werner Kyle and ourselves, the Utrecht Java user group, are actually running for an associate seat. If you are a JCP associate member, you have the right to cast 2 votes. So if you think we could contribute more and more and more to the future of Java, please either vote of us or let other people know that we are running. How to become a JCP member? Come find me after this talk to explain you more. It depends on whether you're an individual, a company, or a non-profit organization. For now, thanks a lot. Please do follow me on Twitter if you think we have something to talk about or just to see what I'm posting. That was it.